Anyone who has ever walked across a dark bedroom in the UK knows the unique, blinding agony of stepping on an upturned British power plug. With its three rigid, rectangular brass pins pointing straight up, it functions like a modern-day caltrop. It is bulky, awkward to pack, and a constant hazard to bare feet. Yet electrical engineers around the world widely consider this heavy plastic brick to be the safest domestic power plug in existence. To understand why it looks and acts the way it does, we have to go back to post-war Britain. The country faced a reconstruction effort that required the physical rebuilding and electrification of millions of homes. There was just one logistical hurdle. The war had completely depleted the nation's supply of raw materials, creating a crippling shortage of copper. They couldn't afford to wire homes the way the rest of the world did. That material scarcity forced British engineers to rethink the rules of domestic electricity. This blueprint compares standard wiring to the British solution. Instead of running multiple separate wires out to individual outlets, engineers invented the ring final circuit, a single, continuous loop of wire that starts and ends at the distribution board. It used significantly less copper, but it delivered a massive 32 amps of power throughout the home. Delivering 32 amps on a single loop created a mismatch. A wall breaker designed to handle that much load is too high rated to protect the thin, fragile wire of a bedside lamp or a radio. If a short circuit happens in a small device, that thin cord will draw too much power, turning incandescent and catching fire long before the 32 amp wall breaker ever detects a fault to trip. To manage this risk, engineers moved the primary protective mechanism out of the wall and placed it directly into the plug itself. This technical diagram outlines the dimensions for a solid link used for testing the fuse clips. Every UK plug is required to house a ceramic cartridge fuse securely inside these clips. It acts as a sacrificial weak link. If a fault occurs, this fuse is designed to melt in as little as 4 milliseconds, cutting the power before the appliance cord can overheat. On the exterior, the top earth pin is precisely 4.6 millimeters longer than the live and neutral pins below it. This profile shows exactly how that length works. Because it extends further, the earth pin connects first, ensuring that the appliance is grounded before the live power pins make electrical contact. This longer pin also serves as a mechanical trigger. As it enters the socket, it depresses a latch that slides protective shutters away from the live and neutral holes, allowing the power pins access to their contacts. This purely mechanical system prevents accidental contact with live parts. Without that specific earth pin pressing the internal lever, the shutters remain locked, neutralizing the risk of a child probing the socket with a metal object. The base of the live and neutral pins also features plastic insulated sleeves. This insulation stops an electric shock if a conductive object, like a coin, drops behind a plug that is only partially inserted into the wall. Even the cable entry is engineered for safety. The cord exits the plug downwards, which prevents it from being accidentally unplugged by side-on bumps or lateral strain. This internal layout shows the precise length of the wires. The brown live wire is cut to be the shortest, the blue neutral has a bit more slack, and the green and yellow earth wire is the longest. If the cord is violently yanked from the plug, the live wire snaps off its terminal first to kill the power. The protective earth wire is always the last to break, providing a continuous safety path until the very end. Every physical dimension of the BS1363 is designed to fail safely under extreme mechanical stress. To appreciate this architecture, we have to look at how other global standards handle the same electrical physics. The standard 2-prong US plug lacks an earth pin, relies on sockets with no internal shutters, and uses flat blades of fully exposed metal that can be touched while plugging or unplugging. The European Schuko plug uses recessed sockets to prevent contact, but it has no internal fuse. It is also unpolarized, meaning the plug can be inserted either way, which swats the live and neutral paths inside the device. Neither system possesses the redundant, layered, defense-in-depth architecture found in the UK standard. The BS1363 functions as an integrated safety interface, incorporating multiple layers of redundant protection, which brings us back to the floor of that dark bedroom. The flat back and the rigid triangular pin arrangement ensure that when the plug drops, it almost always lands pointing straight up. That unyielding physical bulk is required to house the fuse and the mechanical triggers that protect a home from electrical fire. The agonizing pain of stepping on the plug is a byproduct of the same rigid dimensions that ensure a continuous path to ground and a fail-safe electrical connection.